Hello everyone, welcome to this video. In this video we'll be solving this question. This is a very interesting question. Here you will be let's first of all look at the question. In this question they are saying that compute the orders of the following groups. Now they have grouped these three different groups into part A and all different three groups in part B, C and D respectively, right? So they are asking you to calculate the order of all of these 12 groups within given to you, and on the basis of your answers they are asking you that make a conjecture about the relationship among the order of u of r, u of s and u of rs. Now notice that if you have u of 3 here, u of 4 here, you have u of 12 here. 12 is what? 12 you can write as 3 into 4. Similarly 35 is what? It is the product of 5 and 7. Similarly, what is 20? 20 is the product of 4 with 5. And what is 15? 15 is the product of 3 with 5. So they have given you the groups in such a way that you can have a relationship among these orders, correct? The order of u of the product of two elements is equal to what? They are asking you that. Now first of all, what is this term conjecture? If you know, conjecture is based on examples. We are stating that this relationship or this condition could be true. It may not always be true because it has not yet been proved, but it could be proved in the future. So that is why we call it as conjecture at the first place and not the direct result, correct? It is not any theorem or result because it has not yet been proved. Okay, so this is called a conjecture. Okay, now let's first of all compute the orders of the following group. For the first part, we first of all know in U3 there actually in UN what kind of elements are present. The elements are present which are less than n, right, such that when you calculate the mod n of x, you obtain what? The x and n, they should be relatively prime to each other. So basically the GCD of x with n should be equal to 1. This is the condition. So all such elements would be present here. So for U3 you are looking for all the elements which are less than 3 such that the GCD of 3 with all such elements is 1. So clearly the elements are 1 and 2, right? Now because there are two elements, the order is 2. Correct. In U4 you are looking for all the elements which are less than 4 and are relatively prime to 4. So the elements are 1 and 3. 2 is not there. Why? Because the GCD of 2 with 4 is equal to 2 and it is not equal to 1, right? So therefore the order of U4 is also 2 in this case. Now let's see what is the order of U12 and can we have anything in relation with these orders. So for U12 we are looking for all the elements having GCD with 12 as equal to 1, right? So obviously 1 is there, 2 is not there because the GCD of 2 with 12 is equal to 2, which is not equal to 1. 3 is also not there because GCD would be 3. 4 is also not there because GCD would be 4. 5 is there, yes. 6 is not there because GCD with 12 would be 6. 7 is there. 8 is not there, right? Because they have numbers common, right? Then 9 is not there because they have 3 in common. 10 is not there because they have 2 in common. 11 is there. So we only have 4 elements here, hence the order of U12 is 4. In a similar manner we can compute it for the part B, C and D. For part B you can see that when we have U5 we have 4 elements within it, hence the order is 5. In a similar manner you can compute what is U7. It contains 6 elements within it, hence the order is 6. U35 it has 24. You can count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 elements within it, hence the order is 24. Right, so you see the relationship. Here we have 4, here we have 6 and here we have 24 and here we have 2, here we have 2, here we have 4, right? Now let's move on to the third part. Here in this part we have in U4 2 elements, in U5 4 elements and in U20 you see we have 8 elements, correct? So you see the numbers here. Can you make any relationship until now? If not, let's also look at the D example, D part, where we have U3, the order of U3 as 2, U5, the order of U5 as 4, and U15, the order of U15 is 8. So here also we have the numbers 2, 4 and 8. So can you make any relationship here? The answer is very simple. Yes, you see, when you multiply 2 with 2, you get 4, right? When you multiply 4 with 6, you get 24, correct? When you multiply this 2 with 4, you get 8, correct? And when you multiply this 2 with 4, you get 8, correct? So what conjecture can you make out of this? We can clearly say that the order of URS is nothing but the multiplication of the order of UR with the order of US, correct? So this is the relationship that we can construct out of the orders of U of R, U of S and U of RS. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.